So this next problem says a diesel truck develops an oil leak. The oil drips onto dry ground in the shape of a circular puddle. Assuming the leak begins at time 0 and that the radius of the oil slick increases at a constant rate of 0.05 meters per minute, determine the rate of change of the area of the puddle 4 minutes after the leak begins. So this is going to be a related rates problem. So the goal is to determine the rate of change of the area of the puddle. So our goal is going to be to find dA dt. We were told that our puddle is circular, so the area of a circle is pi r squared. If we take the derivative of this function, we get dA dt equals 2 pi r dr dt. So we were given in the problem that dr dt is increasing, so we need to make this a positive 0.05 meters per minute. So all I should have to do now is plug in r, plug in my rate, and that will give me my dA dt. However, I do not have an r value for this particular moment in time, but I was told that this is happening 4 minutes after the leak begins. So we can calculate the value of r at that point in time. So r, we know, is the rate that r is increasing is 0.05 meters per minute. If I multiply that by 4 minutes, we can see that minutes will cancel, and we get 0.2 meters is the value of r at that location. And so we're allowed to do this because we were told that this rate is constant. It's not changing. It's every minute it grows by 0.05. So now I can go back to my function and say that dA dt is 2 pi r, my r is 0.2 meters, times my dr dt, which is 0.05 meters per minute, and this works out to be 0.02 pi meters squared per minute. So remember, with related rates, it's always the derivative with respect to time, and you want to do a units check to make sure the units in the numerator match the appropriate units of the rate that you're solving for. So this meter times this meter gave us meter squared. That is in fact area over time, and it's good enough to stop right here.